Hello students, today we will study about the criteria for similarity of triangles. This is the topic of standard 10 chapter number 6 triangles. So we know that if we have already studied that if two polygons are similar, then there is the two conditions are there. First one is their angles must be equal and their sides are in proportion, right? So suppose there is a triangle ABC and another triangle DEF is there. So to have both the triangles to have a similar, this condition must be there, that angle A must be equal to angle D, B is equals to E, and C must be equal to angle F. This is the first condition. Then their corresponding angles must be equal. Now the second thing is that their corresponding sides, that means AB upon DE, the ratio of these two sides is equal to BC upon EF and is equals to CA upon FD. If these two conditions are satisfied, then we can say that the triangle ABC is similar to triangle DEF. Now we can write down it in this form: triangle ABC. This is the symbol of similarity. Triangle ABC is similar to triangle DEF. So symbolically we can represent these two situations as this, right? Okay. So this is how we can prove. If we want to prove the two triangles similar, then we have to apply. Then we have to check these two conditions in the two triangles. So basically here six properties of the triangle here: three angles and three sides. Now we know that whenever we are proving the congruence of the two triangles that we have already studied in standard 9, we do not need to prove all the six properties are equal. Minimum properties that we have to prove is only three. Either that three must be all the three sides, either two sides one angle, or two angles one side, or right angle, hypotenuse and side. So minimum three properties of two triangles must be equal. Then we can say that the two triangles are the congruent. In the same way, when we are proving the similarity of the two triangles, we do not need to prove all the six criteria, right? We must have to prove only three criteria. We must have to check only three criteria. So out of that, first criteria that we have to study is in the form of the theorem, that is theorem 6.3. And what is the statement? If in the two triangles corresponding angles are equal, then their corresponding sides are in the same ratio or proportion, and hence the two triangles are similar. So here one of the conditions we have given that the two triangles are there and their corresponding angles are equal. That means all the three angles here we have given equal. So we have to prove that the corresponding sides are also in the same proportion or in the same ratio. And if we can prove that this thing, we can say that the two triangles are similar. So see, here we are considering these two triangles ABC and DEF, right? Okay. So currently we can see that the two triangles are not have the same size. This is the smaller size triangle, this is the greater size triangle. But one of the conditions we have given is that angle A is equals to angle B, angle B is equals to angle E, and the third condition is angle C is equals to angle F, right? That means the corresponding angles are equal. Here we have given that corresponding angles are equal. Now what we have to prove? We have to prove that their corresponding sides are in proportion. That means AB upon DE must be equal to BC upon EF, BC upon EF, and the third side CA upon DF, CA upon DF. This is the thing that we have to prove, that the corresponding sides are in proportion. Okay, so to prove this, let us first of all, this is the smaller triangle, this is the greater triangle. So we can cut this much of the portion in this triangle. So let us, if we cut this and give it the name DM. Also the same side AC, if we cut from here, so suppose from this point we can cut and give it the name N. What we are doing here? We are cut the DE side into the two part, DM and ME. Now what is the DM? DM is equals to AB. AB is equals to DM. In the same way, AC side and DN side, now AC and DN will be equal because we cut this much of the portion from this triangle and this much of the portion from this side. So these two sides are now equal. AB is equals to now DM and AC is now equal to DN. Now see, two triangles ABC and DMN. Triangles ABC and triangles DMN. So in both this triangle, three conditions we have here is that AB is equals to DM, AB side is equals to DM side. Now angle A and angle D are equal, that we have given. Angle A is equals to angle D. And the third condition is that AC is equals to DN. AC is equals to DN. That we have do by the construction, right? So this is the side, this is the angle, and this is the side. So here you can say that triangle ABC and DMN are congruent according to the side angle side criteria. So triangle ABC is congruent to triangle DMN according to the side angle side criteria. Now these are the congruent triangle. So now we can write down that all the corresponding parts are equal. So angle B must be equal to the angle M, right? Angle B must be equal to angle M. And see, angle B is also equal to angle E. That means angle B, M and angle E, all the three angles are equal. Angle B is equals to angle M according to the CPCT, and angle M and E are also equal. Here also we can write down that these two angles are equal, because here we have given that angle B and E are equal, and here we prove that and B and M are equal. That means all the three angles are equal according to the CPCT. Now if M and E are equal, that means these two angles are making a pair of corresponding angles, and if the two corresponding angles are equal, then we can say that MN is parallel to EF. This is we can write down as according to the corresponding axiom that we have studied in standard 9, right? Here we can say that MN and EF are the two lines, NE is the transversal or DE is the transversal, and if the corresponding first of all we do not have given that the two lines are parallel. Here we can consider that MN and EF are the two lines, one of the transversal DE intersecting two lines, such that these two angle M and E becomes equal, so that according to the converse of corresponding angle axiom, we can say that this MN is parallel to EF. Now see, MN and EF are parallel. So according to the theorem 6.1, now we can write down that dm upon NE is equals to dn upon nf. Right? Okay, this is according to the theorem 6.1 or basic proportionality theorem. Now One more result we can write down, that is dm upon de, dm upon de, the whole side, that is equals to dn upon df. Right, this result also we can write down. Remember that this result we have already studied in example number 1 of this chapter, right? So now dm and dn, see dm and dn, here we can write down dm is equals to ab. Why? Because here we have proved that ABC and DMN are the congruent triangle. That means AB side must be equal to DM side. So here instead of DM we can write down, AB. So AB upon DE is equals to, instead of DN, now instead of DN what we can write down, AC upon DF, right? According to, as we have already write down here, when we construct this M and N, right? We have write down that AB and DM are equal, AC and DN are equal. So here we get the result that AB upon DE is equals to AC upon DF. Now see this, what this result, what represents, that this side of one triangle upon this side, corresponding side of another triangle ratio is equals to this side AC of first triangle upon this side DF of another triangle. So these two sides are now in the same proportion. Give it equation number 1. Now the same result we can prove that like this, AC AB upon DE is equals to BC upon EF. BC upon EF. We can write similarly, we can write down this result and give it the equation number 2. Right? So how we can write down similarly? Here we have taken DM in which is parallel to EF. We can take this MN here, or that is parallel to DF, and then we can get this result. Right? So this is, if this and this from 1 and 2, from equation number 1 and 2, what we can write down, that AB upon DE is equals to BC upon EF is equals to AC upon DF. So this is C. This result is what that we have to prove. AB upon DE is equals to BC upon EF is equals to CA upon DF, or AC upon DF. That means all the three sides, corresponding sides, are now in the proportion. We have given that only if the three angles are equal, then their corresponding sides are also in the proportion that we have proved. So that here we can say that this triangle, true triangle ABC is similar to triangle DEF, and this is what is the statement of theorem 6.3, and this is its proof. Right? So in this way we can prove this criteria. This criteria is also called, see here three angles we have given. So we can say that the criteria is angle, angle, angle. So this is the first criteria to prove the two triangles similar, and it is angle, angle, angle. That means only three angles we have to keep in mind. If the three angles are equal of the two triangles, then the two triangles are called the similar triangles. Now think about one thing. If only two angles we have given, that angle A and D are equal, B and E are equal. According to the angle sum property, if these two triangle of two angle of this triangle and this two angle of this triangle are equal, then obviously the third angle will also be equal. So there needs only two angles. That means if the two angles, this is the least required condition to prove the two triangles similar. If only two angles of the two triangles are equal, then we can say that the two triangles are similar, because the third angle will automatically be equal. Right? So this is all about the first criteria, and this is all about this angle criteria of the similarity. Okay, this is all about this lecture. Thank you.